Space is supposed to be silent. That's the comforting idea, at least. A vast, empty darkness where nothing moves, nothing watches, nothing listens. But for decades, we've been pointing our instruments into that silence, and sometimes something answers. In 1977, at the Big Ear Radio Observatory, a radio telescope was scanning the sky as part of the search for extraterrestrial intelligence. It wasn't looking for voices or messages the way we imagine them. It was looking for patterns, signals that stood out from the constant background noise of the universe. Most of that noise is natural. Stars, galaxies, radiation, all of it blends into a kind of static, predictable, explainable. But on August 15th, something cut through that static. A signal appeared, strong, narrow, precise. It lasted for 72 seconds. That might not sound like much, but in radio astronomy, that's an eternity, long enough to rule out random interference, long enough to notice something strange about it. The signal matched what scientists had predicted an artificial transmission might look like. It came from a very specific frequency, one associated with hydrogen, the most abundant element in the universe, a kind of universal marker. If you wanted to get someone's attention across the cosmos, that's where you'd transmit. The astronomer reviewing the data, Jerry R. Emmon, circled the signal on the printout and wrote a single word beside it. Wow. That's why we still call it the wow signal. And then it was gone. No follow-up, no repetition, nothing before it, nothing after it. We've pointed more powerful telescopes at that exact spot in the sky for decades since. We've never heard it again. Maybe it was a natural phenomenon we don't yet understand, a rare cosmic event, a coincidence so unlikely it feels intentional. Or maybe it was something else, something that transmitted once and stopped. Years passed, and the universe stayed mostly quiet. But recently, we started detecting signals that are even harder to explain. They're called fast radio bursts. These are incredibly short flashes of radio energy. They last for milliseconds, literally thousandths of a second. But in that tiny fraction of time, they can release as much energy as the sun does in days. Think about that for a moment. Something, somewhere, is producing an amount of energy we can barely comprehend, and doing it almost instantly. At first, we assumed they were one-time events, catastrophic cosmic explosions, colliding neutron stars, exotic, violent processes at the edge of physics. But then, we found something that didn't fit that explanation, a repeating source. In 2016, astronomers confirmed a fast radio burst known as FRB 121102. Unlike the others, this one doesn't just flash once and disappear. It comes back, again and again. Not on a clean schedule, not like a ticking clock. Sometimes there are bursts close together. Sometimes there's nothing for long periods. It's irregular and unpredictable. And that's what makes it unsettling. Because repetition suggests a process, a system, something ongoing. We've traced this signal back to a distant dwarf galaxy, billions of light years away. Whatever is causing it is incredibly far and incredibly powerful. Scientists have proposed explanations, magnetars, highly magnetized neutron stars capable of producing extreme bursts of energy, and that may be the answer. But even now, there are details that don't quite line up, patterns that don't fully make sense. And when something repeats but not predictably, it starts to feel less like an explosion and more like something turning on and off. Around the same time, astronomers noticed something else. Not a signal this time, but a star behaving in a way that shouldn't be possible. It's known as Tabby Star. Located over 1,400 light-years from Earth, this star does something no other star has been observed doing. It dims. That part isn't unusual on its own. Stars can dim when planets pass in front of them. Dust clouds can block their light. But Tabby's star doesn't dim in a regular, predictable way. Its brightness drops suddenly, irregularly, sometimes by as much as 20%. That's far too much for a planet to cause. Even a massive gas giant would only block a small fraction of the light. So what could cause such dramatic, uneven dips? One idea is a cloud of dust or debris, fragments of comets or shattered planetary material drifting in orbit. That's the most accepted explanation right now. But when the data first came in, another possibility was massive structures, artificial ones. The idea of a Dyson sphere or similar megastructure, something built by an advanced civilization to capture the energy of its star. It sounds like science fiction, and it probably is, but for a moment the data didn't rule it out. And that's the uncomfortable part. Not that it's the most likely explanation, but that it wasn't immediately impossible. When you start putting these pieces together, the unexplained signals, the repeating bursts, the stars behaving strangely, you begin to see a pattern. Not a clear one, not a proven one, but a pattern of gaps, things we don't understand yet. And that leads to a much bigger question. If the universe is so vast, where is everyone? There are hundreds of billions of galaxies, each one with hundreds of billions of stars, around many of those stars, planets. Statistically, life should not be rare. Intelligent life should not be unique. By all reasonable expectations, the universe should be full of signals, civilizations, activity. And yet, we hear almost nothing. This contradiction is known as the Fermi paradox. The idea that, given the scale of the universe, the silence makes no sense. There should be something, but there isn't, or at least not much. And one possible explanation for that silence is deeply unsettling. It's called the Great Filter. The Great Filter suggests that somewhere along the path from simple life to advanced civilization, there is a barrier, a point that is incredibly hard to pass. Maybe life rarely begins at all. Maybe simple organisms almost never evolve into complex ones. Or maybe intelligent civilizations tend to destroy themselves. War, environmental collapse, uncontrolled technology, something that stops them every time. And here's the part that should make you pause. We don't know where the Great Filter is. It could be behind us, which would mean we're incredibly rare, one of the few civilizations to make it this far. Or it could be ahead of us, waiting, something that almost no civilization survives, something that explains the silence. Because if intelligent life is common and long-lasting, the universe should be loud. It should be full of signals, overlapping, constant, impossible to ignore. But it isn't. Instead, we get fragments, a 72-second signal that never repeats, millisecond bursts from across the cosmos, a star that dims without a clear reason, pieces of a puzzle that don't quite fit together. And maybe one day we'll explain all of them. One by one, they'll become understood, predictable, no longer mysterious. That's how science works. But until then, we're left with the silence and the possibility that it isn't empty, just distant, or rare, or already gone. Because if the universe is full of life, we should be surrounded by evidence of it. And if we're not, then either we are alone, or something has made sure that most others don't last long enough to be heard.